Welcome to a tutorial of ProfLearn YouTube channel. In this particular video, I want us to discuss and look at different questions that were asked 2025 of 9702. This is A-level physics. So from the screen you can see candidates were tested on the definition for radian. What do we mean by the term a radian? And I'm trying to come up with the definition that will enable you to be able to identify that. And a radian can be defined as the angle subtended at the center when the arc length is equal to the radius. Now in this question, also you are supposed to work out angular speed. And for you to work out angular speed, you need to remember the fact that linear speed is equals to angular speed times the radius. Then now if you make w the radius, we will make w the subject of the formula, you are supposed to arrive at 37 radians per second. Next, we were supposed to work out also the period. The question, we were expected to work out the period, which means that if you work out the period from angular speed 2 pi over t, then we can make t the subject of the formula, which means that now this is the main formula we're going to use with the angular speed that we have gotten from the previous part, and that is going to be 0.17. Roman 3, we were asked to show the distance moved by point x on the chain during a full revolution of the small cog. So meaning that the distance moved by x is equal to the circumference of the small cog, and the circumference of the small cog can be given by 2 pi r, since the angle is we know s is equals to r theta, yeah, or theta r, distance covered when angles are given in radians. So which means that if you apply the formula here, you are going to get your answer being equivalent to 0.24 meters. So the only thing that you are supposed to understand at that point is that distance covered by point x along the chain is equal to the circumference of the small cog. Then we are supposed to, we have Roman 3, yeah, Roman 3 is the one that we have worked out. Then we have Roman 4, I think I might have left this out. We're going to have Roman 4 here. And Roman 4, you are going to use the formula S is equals to R theta. And in that case, you are going to say 0.4, because you are supposed to use the information in Roman 3 to determine the angle through which the large cog rotates. When this covers 0.24, the large cog is going to rotate by which angle? So the distance it will rotate, it will cover, of course, is 0.24, which is going to be equals to the angle which we don't know times the radius of that large cog, which is 0.15. So our theta, you can see now for this case, if we work it out, our theta is equals to 0.24 divided by 1.5, and that is going to translate to 1.6 radians. So this is going to be 1.6 radians. And then the next question we asked, the chain in bicycle B is moved onto a smaller cog fixed on the rear wheel, and the speed of this bicycle does not change. So in that case, we will say that linear speed at point x decreases because as been moved to a small cog, the linear speed is going to decrease, so the angular speed of the pedal decreases as well. The next topic was based on gravitational field in question 2. And now gravitational field, you are supposed to state or what the gravitational fields lines indicate. We are going to say that shows the direction of the force acting on the test mass placed in that gravitational field. And you need to remember also that from a point mass, the direction, the fields are going to be radial like that, and they are going to be directed to the object, and it's like they are going to meet at the center. Yeah, we were also asked in that question to label the magnetic poles using letter N and S, but this was given. This one here was given, so meaning that and this one here, the white ones were given, so meaning we could use that because the fields are entering, that would be the south, fields are getting out, that would be the north, and then we were out to add the fields in that way. Then we are also supposed to use answer in A Roman 2, explain why the observed gravitational field does not vary around the surface. Yeah, so when you look around the surface or near the surface, these fields are perpendicular. All of them, they're perpendicular, and they are equally spaced and evenly spaced. So we are going to say this, the surface, the fields are evenly and perpendicular to the surface. So that is why we can say they do not vary on the surface. They are evenly spaced and perpendicular, directed towards the surface. Next is with reference to B Roman 2, describe the observation made on the field that varies around the surface. You can see at the equator or near the equator, they are weakest because they are far apart, and also they tend to be parallel at the equator, but at the poles you can see they are perpendicular and they are very close, so meaning they are very strong fields at the poles. At the poles we have very strong fields. Here we have weak. The equator, around the equator, we have very weak fields. The next question, in question 3, candidates were tested on the definition of specific capacity. They were supposed to define what we mean by specific capacity. In that case, students were to say amount of thermal energy that is required to raise the temperature of 1 kg of a substance by 1 degree Celsius. Number 2, or part B Roman 1, the students were supposed to work out the mass of the block. What they were supposed to remember is that density is equals to mass over volume, and then they were to use the information that is provided in order to arrive at 9.752 kg. Roman 2 of B, volume, we're supposed to show the volume at 500 degrees Celsius. Yeah, at 500 degrees Celsius. Now in this case, you were to use the density at 500 and then the mass that we had gotten in the previous question, so that you can be able to get that. And if you work it out, you'll get your answers 3.722 times 10 raised power -3. Basically, that's what we were supposed to do at that given point. And if you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. In Proflan YouTube channels, we do maths and physics, Cambridge EdExcel, and also IGCSE. So take some time, subscribe just to support Proflan. All right, so moving to the next bit here, you are supposed to calculate the work done, so that the work done, determine the magnitude of the work done. So something that you ought to, a student ought to have to remember in this is that work done is equals to pressure of a gas times change in volume. So if you will use the pressure that was provided and you subtract the two volumes, you'll get the change in volume, and then you realize the value that we have is going to be 11.1 joules. Also, we were supposed to explain the work done on the block is whether it's positive or negative. So remember, if a gas is expanding, it means that it's doing work to the surrounding. Yeah, it's going to do work to the surrounding. But if a gas is being compressed, it means work is being done to it. So in this case, we were supposed to explain whether the work done on the block. So since this block is expanding, it means it's going to do work to the surrounding, which is doing positive work to the surrounding. Then it means that the work that's done to it is negative work. So work done is negative. Now, using the first law of thermodynamics, we know that internal energy is equal to the energy supplied minus the work done on the surrounding. And then we have gotten the work done the surrounding, which is 11.1. So something that don't confuse and start using again negative here, because this W here is the work done to the surrounding. Yeah, and that work that's done to the surrounding is positive work, so you're going to substitute here. And then this was given the question, the energy that the internal energy. Then we are to work out the energy that was applied. In this case, we realize that the energy is going to be 4.83, but you can see now this 4.83, and even if we take this on the other side and add, it doesn't have really any much of the implication in this particular question. So work done is actually negligible, it's not affecting anything here. And now once you've gotten the quantity of heat, you are going to use the formula Q is equals to MC change in liter in order for you to work out the specific capacity. Then we were asked that further calculations suggest, with reasons how doubling the pressure. If you double the pressure, the work done is going basically to increase, but the amount of work, the energy or the work done to the surrounding is quite negligible. Is not going to affect the value here. So work done is negligible compared to the change in the internal energy. So the answer is going to remain the same. The answer is not going to be affected in any way. So basically that's what you are supposed to say at that point. The next question was testing on ideal gases, and you can see we have different quantities, that PVA is equal to NBT. You are supposed to give the meaning of the symbol T, and that was thermodynamic temperature. The symbol B is the molar gas constant, and the next bit was meaning of M is the mass of, in this particular case now, M is the mass of one molecule of an ideal gas, and this is the mean square speed of the gas. Then candidates were asked to derive the expression in terms of NB from these two formulas that were provided at this point. And students, what they were supposed to understand in order to derive that is that the first equation you divide by a both sides, and then you're going to remain with PV is equals to NBT. But PV, we can see it's a third, and M mean square speed. And then you can be able to substitute it now at this level. If you cancel N both sides and squaring or multiplying, not squaring, this is actually, I need to cancel this. I need to cancel that. This is not squaring. I don't know why it's not multiplying, guys. It's not, the software is not really working. Multiplying 3/2 both sides, I'm going to have a half MC squared. The reason as to why I'm multiplying 3/2 both sides so that I can target and have the equation of kinetic energy. That's just targeting that. There's no fancy reason as to why I'm doing this, just to have a half MC squared, then we can have our equation reducing to this, and that's exactly what we are supposed to show. The next part is where students were supposed to plot a graph to show how the graph of root mean speed and thermodynamic temperature takes place or look like. So meaning that kinetic energy, from kinetic energy you can be able to make C subject, and you see I squared, you find a square root, then you are going to have these terms here. This is a constant and root t. If you are given y equals to root t, the equation will look like that, because these guys here, these are just constant. So you can see C is directly proportional to the square root of thermodynamic temperature T. Then the graph will look like that. In question number 5, this is the question from simple harmonic motion, whereby you are supposed to define what we mean by the term simple harmonic motion. And then you are to say there, this is a type of motion in which acceleration is directly proportional to the displacement, and acceleration is always in opposite direction to the acceleration at the displacement. And if you are to represent this equation, this is a simple harmonic motion, and v is equal to 0.56 cos 16t. From here we can be able to see this value 16 is actually representing the angular frequency, and 0.56 is the original velocity, initial velocity. So which means funga hiyo mlango, which means that we are going to have omega is equals to 2 pi over t. So if we make t the subject, you are going to get that the time period is going to be 0.39. Once you have this, you are now asked to work out amplitude. In this case, we are asked to work out what? Determine the amplitude. And amplitude equation, we are going to use this particular equation at this point, and because we know v naught is 0.56, omega is this value that we had here 16, and then if you work it out, you're going to get 0.35. And lastly is use the answer in B to determine the equation of v in terms of displacement of the block. Basically that's what you are supposed to do. And to draw also the graph of simple harmonic motion, the graph gonna look like that. Of course, this point here represents omega, angular speed, times amplitude. Yeah, that's what this value represent. Yeah, you can be able to have those values, which they should be around 0.5 something. Until next time, see you guys in the next part of this discussion. If you are new to Proplan YouTube channel, consider subscribing so that anytime I'm going to upload another tutorial, you'll be notified. See you in the next video.